So today we are discussing the transportation problem as a special case in a linear programming. There are total three methods, which are the northwest corner method. It is also known as NWCM. The second one is least cost method, which is known as LCM. The third and last method to solve the transportation problem as a linear case, special linear case in linear programming. The third is Weigel's approximation method. So now today we are learning the northwest corner method. That is first method. So how to solve the northwest method? There are some steps. So to solve the northwest cost corner method, it is known as per the name, we solve our problem always with the north corner of the table. So step one is so check the given TP is balanced, the transportation. So check the TP is balanced. What is the means by balanced TP? So the demand and the supply, it must be the equal number of the cost. So the counting of the demand value and the counting of the supply values must be equal. The step 2. What is the step 2? Choose the topmost north corner cell of the table. So second rule or the second step of this northwest corner, choose the topmost north corner of the cell. Means this is the table like this. It has the many columns and rows. So always choose the top north corner. Means first we choose this corner, then make the first allocation here. Now the step 3. Make the appropriate change in supply demand, and strict out the row and column accordingly, and the strict down the row and column accordingly. So this is the third step. And the last step number 4. What is the step number 4? Go to step number 2 and repeat until we all make the allocation for all rows and columns, and make the all allocation. Then we find out after going all steps, we find out the optimal solution. So last year in university I asked this question for 3 marks. This is the question for 3 marks. What is the question? Use the northwest corner rule to obtain the initial basic feasible solution of the following transportations. So now we are solving this problem. So this is the first problem. First, what I have to check? The first step, is this the transportation problem is balanced or not? So how to check it is balanced or not? So number of demand is equal to number of supply. So we count the number of demand, that is 9 plus 10 plus 11, which is equals to 30. And now we count the supply, 12 plus 4 plus 14. 12 plus 14 plus 4, that is also equals to 30. So here the supply is equals to demand. That means this TP is balanced. This TP is balanced. So next step, what is the next step? Choose the topmost north corner of the table. This is the topmost. This is 1 2 3 4 5 6 7 8 9. This is the 9 cells we have in table. So choose the top northwest corner cell. So this is the top northwest corner cell. So we make the first allocation here. So rule to make allocation, see which value is less. So here the total supply is 12 and the demands is 9. So between 12 and 9, the 9 is smaller value. So we make the allocation here of 9. So we make the allocation of 9 here, and here the demand is finished. So we make the cut down this 9, and the remaining cells, what are the remaining? 0. So there is no other allocation. So we cut down these two cells, and between the 12 we subtract the 9. So the remaining cells are 4. Now we make the second allocation between the 6 cells. We already remains the 6 cells. We choose the northwest corner of topmost cell. This is this cell. So we are again compare this demand value and the supply value. Here the supply is 4 and demand is 10. So we make the allocation of smaller value. So that is 4. So we make the allocation of 4 and cut down this into the 0. After now subtracting this 4, we remains the 0. And here we subtract the 4 between the 10. This becomes 6. Now we choose, there is no supply of any other. So we cut down this cell. So we know next remains the 4 cells. Here we choose the topmost north cell is 4, which has the cost of 4. Here between the supply and demand, the demand is less, which is 6. So we make the allocation of 6. Now cut down this 6 into 0, subtracting this value, it's remain the 6. Between the 16 we minus the 14, we minus 6, so it's remain 8. Now there is another allocation. Yeah, there is allocation of, so these two cells has get cancelled down because there is no another solution. We only have the 2 left cells. Here the allocation we need is 8 and 4, which has the less is 8. So we make the allocation of 8 in this cell. So it's become the 0, and now it becomes the 4. 4. So here's the only last cell is remaining, where the demand is 4 and supply is also 4. To we'll make the 4 allocation here. So this is the get cancel into 0 and subtract the 4 value from the D3, so it's become the 0. So we get total 5 allocation here. So 1, 2, 3, 4 and 5. Our basic, we have to find the basic solution. So the basic solutions means m plus n minus 1, that is equals to, there are the 1, 2, 3 origins plus 3 demands minus 1. 3 plus 3 is 6 minus 1. There is total 5 allocation. So we got the basic Wheeler solution for the transportation problem here. So now we are finding the cost of this problem. So what is the mean? 9 into cost, first allocation. The second allocation 4 into 1. Then 6 into 4. The next allocation is 8 into 0 and 4 into 7. The total is 9 into 5 is 45. So here we will find out the all multiplications here. The cost of the total, we add the total of these, that is 101. So minimum cost of this problem using the Northwest method is 101. So we get our basic feasible solution for the 3 marks question.